In dealing with questions involving a percentage yield, we need to actually combine some previous concepts, most notably that of stoichiometry, and using that with some knowledge that we need to add in. What we know about any chemical reaction is that no matter how well we do it, no matter how much we can control all the variables, we will not always get 100% of the substance that we intended to. We might get 95%, we might get 75%, or anywhere in between. We might even get a low percentage, but that is a consequence of the way the reaction is carried out, the conditions that we have, among many other things. So we are being asked to look at methanol, which has the formula CH3OH. It's made in a synthesis reaction using carbon dioxide, which is CO2, and hydrogen, which is H2. Forms methanol and water. What we know is that 20 grams of hydrogen was reacted with excess carbon dioxide to produce 102 grams of methanol. Now, I am going to box that off for a minute, and I'll explain why once I finish the question. What is the percentage yield? We know that we had 20 grams of hydrogen. We don't know how much methanol should have been produced in theory. Maybe it was exactly 102 grams, maybe it was more. But that 102 grams we have, this is the actual reality of the experiment. This doesn't come into play until the end, after we figure out how much methanol we should have created in theory. So to do that, we actually go through the standard three-step stoichiometry process. We know that we took 20 grams of hydrogen. We need to determine how many moles of hydrogen that was. To do that, we need to find the molar mass of hydrogen. Well, hydrogen being H2 means we have two hydrogens in it. Looking at the periodic table, each one of those hydrogens weighs 1.008 grams per mole, which gives us a molar mass for H2 of 2.016 grams per mole. We can use that to calculate out the number of moles of hydrogen that we used. Looking at the mole calculation chart, the number of moles is always mass divided by molar mass. So we had 20 grams of hydrogen. The molar mass is 2.016 grams per mole. And I won't take this to sig figs yet because this is only one step of the question. Means that we have 9.9206 moles. And I'm going to be very specific here. I'm going to say moles of H2, just like with the stoichiometry question. Because we are dealing with different substances, we do need to identify which substance we have. So step one is complete. We're going to go on. I'm just going to clear the page for step two. This is determining how many moles of methanol we should have made. And I'm going to add a piece to this. I'm going to say in theory. Because in theory, all of this hydrogen gets used up to make methanol. None of it gets wasted. None of it gets converted into other substances. So in theory. So we take our moles of hydrogen, which was 9.9206. We are going to multiply that by our mole ratios from the chemical equation. I'll just pull that back. For methanol, we have 1 mole of methanol, and we have 3 moles of H2. So we'll multiply by 1 mole methanol over 3 moles of hydrogen gas. Working that out, and again, I'll take extra sig figs. We get 3.3069 moles, which is now how many moles of methanol we should have made in theory. Again, I'm just going to clear a fresh page for step 3. Now that we know how many moles of methanol we should have made, now we can determine the mass of methanol that we should have made. So again, this will be in theory. To do that, we need the molar mass of methanol. Slightly more complex than just hydrogen gas. It has more atoms in the compound. So we have carbon, only one of them. Carbon weighs 12.011 grams per mole. We have 4 hydrogens, 3 here and a 4th one here, so we can just do that all at once. Each hydrogen, looking it up, weighs 1.008 grams per mole. That works out to 4.032. And we have an oxygen, only one of them. An oxygen weighs 15.999 grams per mole. Totaling that up gives us a molar mass of 32.042 grams per mole. And now that we know the molar mass of methanol, we can find the actual mass that we should have produced. Again, going to the mole conversion chart, mass equals the number of moles multiplied by the molar mass. So we should have created 3.3069 moles. The molar mass, 32.042 grams per mole. And this one would give us 106 grams of methanol. Again, this is in theory. This is not the actual amount that was produced. This is how much we should have. So up until now, this has just been a standard stoichiometry question. Now is the point where we need to add in the 102.0 grams of methanol that we actually made, and this is where we can calculate the percentage yield. So the percent yield is, I'm just going to abbreviate the formula, the actual divided by the theoretical times 100%. So we actually made 102.0 grams. In theory, we should have made 106. Working that out, and we need 3 sig figs in this question because of what was given to us, we get that we have a 96.2% yield, which is actually incredibly good. Anything over 90% in an actual chemistry lab is considered successful, so this one was quite successful.